Okay, moving on to solving trig equations. Please notice that we are now solving, not proving, right? So you need to pay attention to the directions. The rules are totally different when you want to solve something. We will be solving for x or theta or alpha, any of those variables. They all represent x. We will isolate the variable by moving all the values to the other side of the equation, anything that doesn't have a sign alpha attached to it. Then we will use any of our trig identities, factoring and zero product property. That one comes up a lot. We are almost always factoring and zero product property. PEMDAS, any algebra that makes logical sense. One huge thing you want to be extra careful about is you cannot divide out a cosine or a sine or any variable, right? So like if I had x squared equals x, I know oftentimes students want to divide by x, but what you need to do is minus the x to the other side, right? Because this is x squared minus x equals 0. Factor out the x, there's that factoring, and you get x equals 0 and x equals 1. Well, if you had done x squared equaled x, and you divided both sides by x, you would get x equals 1. That's one of the answers, but you just lost half of your answers by dividing out the variable. Do not divide out a variable. What you can do is manipulate it, right? Make it one of the identities. So in this example here, if you divide by cosine x, it doesn't cross out, right? Up above, the problem is things cross out. That is not okay. In this one, instead of crossing out, it just transforms to tangent. So that's the difference. Make sure you give all the solutions and check for extraneous solutions. So I will talk about the extraneous solutions when that comes up, but let's just say the answer was 0. This is the unit circle, right? It all comes back to unit circle. 0 and pi. Those were the answers I got. Well, first of all, you can wrap those solutions. So instead of saying x equals 0 and x equals pi, you can wrap it up in a nice little answer because from 0 to pi is a distance of pi units away. And from pi back to 0 is a distance of pi units away. So if you say 0 plus or minus pi n, so that's saying just add pi over and over and over again, or subtract pi over and over and over again, you will keep landing on those same spots. You'll start here, and then you'll add pi and land here, and add pi and land here, and add pi and land here. So let's see, what is this? 3 pi is an answer, 5 pi is an answer, 7 pi is an answer, right? All those coterminal angles. By writing your notation like this, you hit every possible answer. Okay, so let's try our first pretty basic example. So in this example, there's no algebra you need to do to isolate the variable, right? Tan x is already by itself. So we know tan x equals 0. Here's another essential skill where if you don't understand the unit circle, you're not going to pass this skill. Tangent x equals 0. Remember, tangent is y over x. So that means y has to equal 0. So where on the unit circle does y equal 0? Y equals 0 here and here. So coincidence, I should have looked ahead. My answers end up being 0 and pi, but we call it wrapping the solution. The distance from one end to the other is pi, and continue around is pi. So we can write our answer, this one was x, as x equals, either one of those is a good starting point. I'm going to start with 0, and then plus n minus pi n. This is the entire solution. It hits every possible answer, and it's wrapped up in a nice little solution. Don't be surprised if it's multiple choice if they use the variable k instead. That's perfectly fine. Okay, next. Okay, this one we've got to do a little more work, right? We don't have the variable by itself, so add the root 2 to the other side, right? That doesn't have a variable attached to it. And now we need to find all the spots on the unit circle where secant equals root 2. You know I don't like these. I don't want to use secant because I know sine, cosine, tangent so much better. So who's the reciprocal of secant? cosine, and then reciprocals, right? We made a table of reciprocals, root 2 over 2 if you flip it over and rationalize it. So the purple is saying the same thing as the green. Where on the unit circle does cosine equal root 2 over 2? So on the circle, cosine is your x value. It's positive. So cosine's positive in these two quadrants. The root 2 over 2 is the middle ones, right? The ones that go through the middle of the quadrant. So this location is pi over 4. And if I go all the way back around, this location ends up being 7 pi over 4. That's your unit circle knowledge. Now, if I try to wrap these, because you want to try to wrap all of them, the distance from here to here is clearly bigger than the distance from here to here. If those two distances don't match, you can't wrap. So the solutions would be written as x equals pi over 4, but you still have to hit all the positive and negative coterminal angles. So plus or minus 2 pi n, because that's just a full circle. Just keep going around over and over again and landing on itself. And x equals 7 pi over 4 plus or minus 2 pi n. This is how we would write the solutions to number 2. Number 3. Okay, we've got sines and cosines on both sides of the equation. So we want to move everything to the same side. This is all one term, so I'm going to subtract it over to the other side. So I'll have 2 sine x cosine x minusing the root 3 sine x to the other side. Make sure your root's not too long. And now it equals 0. Once it equals 0, I want to do factoring and zero product property. I'm going to say it so many times this chapter. Factoring and zero product property. What do those both have in common? Well, they both have a sine x in common. So that gets factored out as a GCF. It does not disappear. And I factor it out of the inside. Now I have 2 factors. You're welcome to put parentheses around that one if it helps you. And I do zero product property. That factor equals 0. And this factor equals 0. The first one, I can automatically start putting it on the unit circle because it's just sine x equals 0. So sine is the y value. Where does the y value equal 0? It equals 0 here and here. That's going to be in the way. Give me a second. There we go. So same spots. And then for this one, I want to isolate the variable. There's only one x, so add the root 3 to the other side. Isolate the cosine, divide by 2. Cosine x is going to equal root 3 over 2. I'm going to plot it on the same unit circle because I want to try to wrap all these solutions together if possible. So cosine, that's the x value, is root 3 over 2. See if you can plot those on your unit circle. A cosine of root 3 over 2 is here and here. So we want to check and see if we can wrap any of these together. So hopefully you're recognizing that those purple ones can be wrapped together, right? They're a distance of pi apart from purple to purple. But there's no way to include those blues because the big distance is clearly different than the little distance. So for the purples, I'll say x is equal to 0 plus or minus pi n because those arcs are pi in length. But for the blues, each one of those is going to have to get its own equation. So the top one is pi over 6 plus or minus a whole circle. And the bottom one is 11 pi over 6 plus or minus a whole circle. And these are our 3 answers that represent 4 points. Well, technically they represent an infinite number of points that solve this equation. Okay, number 4. So I do want to do number 4 a couple different ways. Why don't you see if you can find a way to do it? So I'm just going to guess here, but maybe you moved the 1 to the other side because it doesn't have a variable on it. And then maybe you square rooted both sides. That's a perfectly reasonable way to do it, but do you remember that if x squared equals 4 and you square root both sides, what can x equal? Well, x could equal 2 or x could equal negative 2. So you have to remember that if you're going to do it this way. So I'm going to put a plus or minus there. So then on your unit circle, cosine is the x value. So a cosine and x of 1 and negative 1. This is happening a lot. It's just a coincidence, just so you understand. Those are pi apart. I feel like it's all we've been doing today. So x equals 0 plus or minus pi n would hit those solutions over and over again. But I also want to show you another way in case maybe you recognize that as a difference of squares, right? Cosine squared, don't forget the x. Minus 1 is a difference of squares, factoring one with the plus, one with the minus. So cosine equals 1 and cosine equals negative 1. It's the same answer. I just wanted to show you that there were two different ways to get there. But I wanted to be sure if you were square rooting both sides that you didn't forget the plus or minus. So this is the same answer because it's the same picture. Okay, number 5. So I have sine x's on both sides of the equation, or variables on both sides of the equation. So we need to move them all to the same equation. Whenever possible, keep your squared positive, right? So let's move the 3 sine x. And then let's make it look like it should. Do 2 sine squared x, and then put the 3 sine x in the middle, and then the plus 1 equals 0, right? We would like our exponents to count down. So again, we talked about this in proof. This is the same thing as 2x squared minus 3x plus 1 equals 0. So if you can factor this, whether you use an area diagram or you can do it in your head, you can also factor this. So there's all sorts of factoring videos, right? There's one from Edpuzzle, and then I think I posted some more somewhere. This factors to be 2xx. The only way to get negative 3 is if I have negative 1, because that'll give me negative 2, and then negative 1 here also. So then if the green one factors to 2x minus 1 times x minus 1, then in the purple one, the x, again, I should circle the middle one, the x just represents sine x. So everywhere I see an x, I'm going to write sine x. 2 sine x minus 1. Sine x minus 1. If you multiply that out in an area diagram, you'll get the same thing. So now we have two factors that equal 0, zero product property. 2 sine x minus 1 equals 0, or sine x minus 1 equals 0. Solve for sine x. 2 sine x equals 1, sine x equals 1/2. I'm going to change colors so we can see them both. Sine x equals 1. So on the same unit circle, we have sine x equals 1/2. Remember, sine is the y value, and it's a positive 1/2. That's a short one, right? Here and here. And then we also have sine x equals positive 1. So positive 1 is up here because it's the y value. Check and see if any of those gaps are the same. Is the gap from here to here the same as back? No. Is the gap from here to here the same as this one? Yes. But is it the same as this one? No. So none of the gaps make a full circle with the same distance. So each one gets its own equation. Pi over 6 is the first one, plus or minus a whole circle. Pi over 2 for the top one, plus or minus a whole circle. And what's over there? 5 pi over 6, plus or minus a whole circle. These are our 3 answers, but really infinite answers that work for this equation. Number 6. It looks like a difference of squares, but 3 isn't exactly a perfect square. Here's something you guys learn in higher level classes. You can still do those. 2 cosine x plus root 3, 2 cosine x minus root 3 is how that factors. So even if it's not a perfect square, you still square root it. You're also welcome to do the move the number to the other side, divide by 4, and then square root both sides. But remember, when you square root it, cosine x equals plus or minus. That's root 3 over the square root of 4 is just 2. And had I finished this one over here, this would be 2 cosine x equals negative 3, root 3. I moved it over. 2 cosine x equals positive root 3. And you'd get the same thing. Negative root 3 over 2 and root 3 over 2. Either way, plot them on the circle. Cosine is the x value, It's positive and negative root 3 over 2. So an x of positive root 3 over 2 are these two. An x of negative root 3 over 2 are these two. Is there any way you can wrap 2 or 3 or 4 of those into one solution? Well, because they're the same line going through the circle, this one and this one, right? Those wrap by a distance of pi. They are pi apart here to here, and then back around are a pi apart. So that's the pi over 6 plus or minus pi n. That hits 2 of them. And then these two are pi apart as well. So x equals, what is that, 5 pi over 6? Pi over 6 plus or minus pi n. Hits all 4 solutions in 2 neatly wrapped equations. Okay, we will practice this more together in class. I hope you guys are doing well.